Hello everyone. We're going to go over multiple linear regression in R. So in the last topic we covered simple linear regression. Now we're going to look at predicting values for a dependent variable using multiple independent variables. And we're going to use the New York City Open Data condo evaluation data. In the text in R for everyone, they create multiple models and play around with the data a lot more than we're going to do. For the purposes of this, we're just going to cover the basics. So I loaded the data into the URL into a URL variable, and then I fed that into the read table function and provided my pretty typical arguments for when we're importing CSVs. And then I renamed the column names so that it would be easier for us to do our analysis. And so when I do this and I load the data, I get some data table that looks like this. I can see I have 13 variables and everything looks like it was imported correctly. So to start before we actually build a model, we kind of want to look at our data and see what we're working with. So to do that, we're going to use ggplot, and we're first going to look at a histogram of the value per square foot. And when we do that, we can see this histogram here is interesting, but we really need a little bit more. So let's color on the boroughs, and when we do that, we get this graph here. So that's a little more interesting now. If we keep exploring our data, we may want to look at the square footage and the number of units first. So we'll make some more histograms, but right off the bat we can see that this data appears to be skewed right. And when we run our units histogram, we can see that there are, so some of those graphs were already filtered. So I removed that filter so that you could see the original histograms. So here's the square footage. You can see that it's very skewed right, and same with the units. So we want to figure out whether some outliers are skewing the data. So we're going to look at units above 1,000 and see how many data points there are that fall above 1,000. When we do that, we see there are 6. So now we're going to remove them. So we're going to take our original data set and we're going to replace it with a filtered data set, and this is how you can filter. So we're filtering on the variable units less than 1,000, and we're pulling all the remaining data from that, all rows. So let's go ahead and filter our data. Now if we look at the histograms, you can see that they're still skewed right, but those major outliers are no longer there. So we get a little bit of a better feel for the distribution. Okay, so if you'd like, you can follow the text to continue to practice. You can make some scatter plots. That will help determine how to proceed with modeling. They actually, based off the scatter plots and the histograms, come to the conclusion that we may need to take logs of the data in order to get better models, but we're just going to run the initial multiple linear regression model with the variables units, square feet, and the borough, and we'll store that in the variable house1 and then look at the results. So we can see right off the bat that the coefficients are significant for all but the borough, the Staten Island borough. And our multiple R squared is 0.6. Our F statistic is right here. We can also kind of look at the residuals. Okay, so that gives us an idea, a basic idea of the model that we can use to interpret. But we can also look at the coefficients if we just want them to print out more nicely. We can use this coef function, And we can use this cof-plot library, which is kind of cool because it creates a visual of our coefficients. And when we do that, we can see that the Staten Island borough variable contains 0 within its confidence interval, so therefore it's not statistically significant. And we can also see that square foot and units have very little effect on the value of a building. So from here, the only other thing we're going to cover is how to make predictions now using the model that we've created. So we're going to read in this file, housing new, from this URL here. And then we're going to use the predict function with our house one model. Our new data is that housing new file. And then we're going to set the confidence level to 95. And so when we upload our data and then run our predictions, we can look at the lower and upper bounds for each of our predictions, and we can also look at the standard error. And we can see it's quite high for variable 6. So that's kind of the basics of multiple linear regression in R. Again, you can follow along in the text to look at multiple models and also compare the coefficients from multiple models as well.